Hi everyone, and welcome to this lecture. This lecture, I want to go over one problem, solving using undetermined coefficient. So let's go over this problem, the details of that problem. And again, the solution is already here. So that's, we can see this is not a homogeneous equation because we have a forcing function here. So the way this works, we're going to solve the homogeneous equation first. Then as this is the solution, m1 equals to m2 equals to m3 equals to 1, and the homogeneous solution, I call it y sub h, or this is the characteristic solution, can be written as that. Please check the notes on the last videos. And here we assume that y sub p is ax plus b plus cx cubed e to the x, and I will go over that right now. And once we substitute, we can solve for a, b, and c. And the final solution, we know it's the homogeneous solution plus the particular solution. Let's see how that works. Now, step number one, solving the homogeneous equation. We know this is, we forget the forcing function in this case. We just put it equal to 0. And we know the characteristic equation is a polynomial. It's going to be n cubed minus 3m squared plus 3m minus 1 equals to 0. How do you solve that? You can use synthetic division, or let me just refresh your memories of calculus. If you see, then it's much faster. So I want to kind of review Pascal's triangle here. It's 1, 1, 1, and then you start always with 1, 1 plus 1 is 2, and you end with 1. Then it's 1, 1 plus 2 is 3, 2 plus 1 is 3, and you end with 1. And I highlighted this because that's what we're interested in. So then we have 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and you end with 1. What are those? These are the coefficients of the binomial expansion. Now I just picked this one because that's what we need. A plus b cubed is 1 times a cubed, which is that number. Then it's 3 times a squared b plus 3 times ab squared, and it should be squared, and plus 1b cubed. What happens here, the coefficients are pretty straightforward. You see it, and the exponents, you start with a is cubed, then 1 down, then it's squared, and you put b, then it's again minus 2 minus 1, here is 1, and b goes up the exponent of p, so it's 2, and finally you have b cubed. One thing to notice, each time you add these exponents, you have to get 3. We have 3, 2 plus 1 is 3, and 1 plus 2 is 3, and this is also 3. So that's a way to see it. If you remember, then you can find this much faster. And if you have a minus b cubed, then the sign alternates. If we come back to our equation, that's what we had. So we know we have 1, negative 3, 3, and negative 1, which are these numbers. So, and a in this case is m, and b is 1. So therefore, if you factor this, then you're going to get n minus 1 cubed. So we know that we have only one solution for that. The way you write the solution, and again, review the lecture or the notes on the homogeneous solution, is c1 e to the x, c2x e to the x, and c2x squared e to the x. Why e to the x? Because m is 1. So these are just m's, which is 1. And you have to write all 3 of them because it's a third-degree equation. Then we know we have 3 repeated. It's 1 root, but it's repeated. Now, how do we solve the particular solution? So this is our equation. The particular solution we have, this is like linear, the first term of that. So you put the first particular solution, you can write that as ax plus b. And for the second particular solution, it's an exponential function, and that's a constant. So you write that as c e to the power of x. but we cannot take that. That's why I'm going over this problem, because that's already in the homogeneous solution. If you go to x e to the x, still it's rejected, and if you go to the cx squared e to the x is also rejected, because these are all in the homogeneous solution, so you cannot take those. Therefore, the second particular solution, we have to write that as cx cubed e to the x. And we know that the particular solution for this one is going to be the first particular solution, which we are going to find, plus the second particular solution. So this is the solution. And once you have the form of the solution or this function, then we have to substitute. So you can have to find the first derivative. The derivatives are pretty long, but it's just using the product rule. The derivative of a x is a, the derivative of b, that's a constant, it's 0. And this one, you can do the product rule, the derivative of the first function, which is 3cx squared times e to the x, the second function, plus the derivative of the second function, which is just e to the x times the first function. So that's the first derivative. Then you have to continue and find the second and the third derivative. It's kind of long, but it's the simple product rule. So for the second derivative, that's the derivative of a is 0. The derivative of this term is the derivative of the first term, which is 6cx e to the x plus e to the x times the first function, which is 3cx squared, and c for this one also product rule, the derivative of the first function, which is 3cx squared e to the x plus e to the x times cx cubed. And again, if you simplify, that's what you get, and you have to keep going. It gets longer and longer. So however you solve this, that's the third derivative, and if you simplify, you are going to get that expression. Now we have to go back and substitute in this equation. We have the third derivative, and I can write that here. So this is y double triple prime minus 3 times the second derivative. You just substitute by expression plus 3 times y prime, and this is just y. And guess what? You have to simplify. So this is pure algebra. If you do this carefully, a lot of terms cancel each other, and I put those here. Then at the end, what you need to do is match the coefficients of the left side and the right side. So here, as we can see, the coefficient here of e to the x is 6c. So you write 6c, and the coefficient of e to the x here is -4, equals to -4. The constant that we have, there's no constant on this side, so it's 0, but the constants on the left side, we have 3a minus b. So you write 3a minus b equals to 0. And finally, the coefficient of x here is 1, and we only have one term, -ax. So -a is 1. That's a simple system. And if you solve that and you substitute, you get a is -1, b is -3, and c is -4/6 or -2/3. And guess what? We have a particular solution, and we found a, b, and c, and you substitute by its values, then you get that. We're not done yet, because one step left. The solution of that equation is the homogeneous solution or characteristic solution plus the particular solution. Homogeneous solution, we found that, and this is the particular solution. You add them, and that's going to give you the solution of the differential equation. A lot of arithmetic and algebra involved, but these are not very hard steps. Thank you for watching, and I'll see you soon in my next video. Have a good one.